All right, in this video, we're going to be looking at graphing proportional relationships. So we've already kind of reviewed what it means for something to be proportional. So let's do a quick little review more of that, looking at these graphs for activity 1. So it says, tell whether x and y are in a proportional relationship and explain your reasoning. So the graph for part A, we're looking at the number of hours worked and how much money you earn. So it looks like when you work 1 hour, you make $10. 2 hours, you make 20. 3 hours, you make 30, and so on. So is it in a proportional relationship? We would say yes. And based on the graph, there is a straight line going through the origin. So remember, for the graph, for it to be proportional, the graph has to pass through the origin, point 0, 0. If it doesn't, then it's not proportional. Okay, sorry about that. So again, on a graph, it's got to be a straight line, and it also has to go through the origin for it to be proportional. So let's look at the graph on B. We're looking at a helicopter. The height in meters over a period of time. So after 1 second, it's at 30 feet, or 30 meters, I guess. After 2 seconds, it's at 25 meters, and so on. So based on the graph, the helicopter is actually landing, okay? But is it proportional? Yes, it's a straight line, but it doesn't go through the origin. So this one is not proportional because the line doesn't pass through the origin. Okay? All right, moving down to part C with tickets. Okay, we have number of tickets and how much it costs. Okay, so looking at the graph, yes, it's a straight line, but does it go through the origin? It's really close, but it does not go through the origin, so no, because the line doesn't go through the origin. Okay, and then the last graph here, pizzas, the cost per pizza. So 1 pizza looks like it's about $6, I would say. 2 pizzas, 12, 3 pizzas, 18. So it's linear. It makes a straight line. Does it go through the origin? Yes, because 0 pizzas would cost $0. So yes, because the line goes through the origin. So that's on graphs. To tell if a graph is proportional, you're looking at if it's straight, if it's linear, and 2, if it passes through the origin. Okay? Now, for E and F, where there isn't a graph, all they give you is a table. We're looking for a constant pattern every time. So let's look at E. We're talking about laps. And the time in seconds. So maybe you're swimming laps or maybe you're running laps. Okay, let's say you're running a lap around the track. 1 lap takes you 90 seconds. 2 laps takes you 200 seconds, and so on. So our laps are increasing by 1, but let's look at the time. Is it the same amount of increase every time? Well, from 90 to 200, that would be, let's see, adding 110. From 200 to 325, that's adding 125. So right there, it's not the same pattern going on. So this would not be a proportional relationship because there is not a constant pattern. You always want to look for that constant pattern. If we were to graph this, it wouldn't even be a straight line. It would kind of curve up. Okay, now F, cups of sugar, cups of flour. So let's say you're baking something. 1/2 cup of sugar, 1 cup of flour. 1 cup of sugar, 2 cups of flour, and so on. So let's see if there's a pattern going on here. Okay. 1/2 to 1, I know I would have to multiply 2. A half times 2 is 1. 1 times 2 is 2. 1.5 times 2 is 3. 2 times 2 is 4. So there is that constant pattern going on. You could also notice that your cups of flour are going up by 1, and then your cups of sugar are going up by 1/2 each time. So yes, this is proportional because there is a constant pattern. Okay, and then obviously if you're not going to make anything, you would have 0 cups of sugar and 0 cups of flour. Okay, we're actually going to skip over a page to part C. Right here, we're now on page 81. Okay, and it says use your result. Part B, that goes with the above. So actually we're going to jump down to number 4. Okay, it says how can you describe the graph of an equation y equals mx? How does the value of m affect the graph of the equation? So we've been talking about lines a little bit. We've been talking about the slope, okay? And I've told you that m represents the slope of the line. So how could that value, how could m affect the graph of the equation? Well, in one of the very first lessons we did about graphing, we said that the slope tells you how steep the line is, okay? So if the slope, or m, is a bigger number, the line will be steeper. It should be steeper right there, okay? And then obviously if it's a smaller number, it's not going to be as steep. So let's compare two slopes. If I had a slope of 1/2 and a slope of 3, which line is going to be steeper? That would be your slope of 3. That will be steeper because it's the bigger number. Okay, the bigger the number, the steeper the line is. All right. Now, let's look at number 5. It says, give a real-life example of two quantities that are in a proportional relationship. Okay, something that would have a constant pattern going on every time, and that would start at 0, 0. Okay, my mind automatically goes to two things. I automatically think of working a job. Okay, so obviously if you work 0 hours, you're not going to get paid. My mind also goes to traveling, okay, and then like the speed at which you're driving. So let's look at actually both of those and I'll kind of explain how they work. So if we're talking about a job, okay, let's say you make $8 an hour, okay, it says write an equation that would represent that relationship and then sketch the graph. So if I make $8 an hour, that's $8 every hour that I work. So you would have to take 8 times the number of hours that you work. I'm going to use H for that. So if I work 10 hours, you take 8 times 10. Okay, that's going to equal Y. So your equation would be Y equals 8H. Now, this graph isn't the best to represent this one, but if I worked 0 hours, I get paid $0. If I work 1 hour, I would get paid $8, which is somewhere up here. So you see how the graph would work. 2 hours, I'd get paid $16, and so on. Now, let's look at that other example when you're driving. Okay. Let's say you're traveling, and let's say you are driving 70 miles per hour. Okay, my two labelings are miles and hour. So if I have driven 0 hours, I have driven 0 miles. Okay, if I drive 1 hour, I've driven a total of 70 miles. 2 hours would be 140. So my equation for this would be y equals 70x, I'll say. So whatever your constant is, in this case it's 70 miles an hour that I'm driving, or with the job it's $8 per hour. It's always y equals that number and then your x. Okay, and then again, my graph isn't going to be very friendly for this situation. Okay, so I want to work through the problems here at 4.3 practice, which is on the next page. So let's look at number 1. It says the amount P in dollars that you earn by working H hours is represented by the equation P equals 9H. Graph the equation and interpret the slope. Okay, so P equals 9H. So H represents the hours. That's going to be down here. P is the amount in dollars that you earn. Okay, so if I work 0 hours, I don't get paid anything. If I work 1 hour, well, 9 times 1 is 9, so I'll put a dot just below 10 here. If I work 2 hours, 9 times 2 is 18. And then you could keep going up and up from there. So we graphed it. Now it says interpret the slope. Anytime it says interpret, you're going to see this word a lot. It means, what does that slope mean? My slope is 9, but what does it mean? In the context of this problem, working and amount of money, what does that 9 represent? That's what they want to know. That's what they mean by interpret. So the 9 means, you've probably figured out by now, that you would make $9 per hour working at that job. Okay, let's move down to number 2. It says the cost in dollars to rent a bicycle is proportional to the number of hours that you rent the bicycle. So if you rent this bicycle, what they're saying by it being proportional is that it costs the same amount every hour that you rent it. They don't change the amount. So it says it costs $20 to rent the bicycle for 4 hours. Write an equation that represents the situation. So remember, our equation will look like this. Y equals mx. M is your slope. The slope is your constant. What is it that you are paying every single hour? Well, if it's $20 to rent it for 4 hours, 20 divided by 4 is 5. It would be $5 per hour. So our equation is y equals 5x. Interpret the slope. Well, my slope is 5, and we've kind of already covered this. What that means is it is $5 per hour to rent the bike. And then how much does it cost to rent it for 6 hours? Well, if it's $5 each hour, 5 times 6, it would cost $30. So that's just a brief little review into graphing proportional relationships.